Dear students, let's start lecture number 12 on the topic Steganography part 3. This is our outline. First of all, I'll revise lecture number 11. Then I'll make a difference between steganography versus cryptography. Then I'll be explaining combination of cryptography and steganography, and this is called Crypto-Steganography, and types of Stegosystems. And then I'll be explaining difference between Steganography and watermarking. So let's start with the revision of lecture number 11, Steganography part 2. If you remember that I have explained image steganography with the help of two examples. One was JPG, JPEG concealing, and other was least significant bit technique. So this is the least significant bit technique. And the least significant bit technique is a very slave way of hiding data images and taking advantages of the fact that small changes in pixel color are invisible to the naked eye. As you know that in colors or in digital images, you have different pixels, and each pixel is represented with three colors like RGB, red, green, blue. So if you make a small change in that by containing the information, by considering the information you want to send over these pixels, so this is invisible to the intruder or the malicious user. So encoding images in red, blue, green pixel colors represented by a combination of certain amount of, like each pixel has certain amount of red, certain amount of green, and certain amount of blue. So each pixel, the amount of red, blue, green is represented in the range of 0 to 255. Pure red would be represented as 25500, means you have all bits representing red, but there is no green and no blue. Like for example, in the red you have all 1, and green they are 0, and blue they are 0, because this is pure red. And if you make a simple change of 1 bit, like for example, if you make a change, like if you have this 111 and you make a change in the last bit, so you will not get any difference. And if you make a 2-bit changes, this is also not visible with the naked eye. So so I'll explain this with the help of example. Suppose if you are sending if you want to send a message SOS to the recipient, and each is represented with their digital or a binary representation, like each character in ASCII is represented in 8 bits, as you know. So S will be represented at 0, 1, 0, 1, 0, 0, and 1, 1. O is represented as 0, 1, 0, 0, 1, 1, 1, 1. S will be represented as 0, 1, 0, 1, 0, 0, and 1, 1. So now split each character into two 2-bit pair. S has the following 4 pairs, like 0, 0, 1, 0, 1, 0, 0, and 1, 1. Spread these pair successively along multiple pixels. So if the image had 4 pixels, message would be encoded like this. For example, you can see here in like if you want to send S, so as S is represented in 4 pairs, and each color is represented with 3 colors. So we will be encoding 2 bit of S in each pixel, like of red, blue and green. Like for example, we have encoded 01, 01, 00 and 11 in the next pixel, and so on. This way, using we we encode all our characters in the pixels and then send to the intended receiver. And if for example, as you are as the change is so small that if it is received by intruder or a malicious user, he will not be able to get that what kind of information you want to send to the receiver. So note, choose to use more than 2 bits per pixel to store message, as I explained. But remember, by using more bit, risk changes to each pixel becoming perceptible. This is very important. For example, you have to make change in such a way that it cannot be observed with the naked eye. Otherwise, if you make changes in too many bits, so then this could be judged by this could be judged by your intruder or malicious user, that you are intended to send something information inside that image or a video. Now, stag analysis is the art and science of detecting a secret information. Hiding a message will most likely leave detectable traces in cover medium. The information hiding processing changes the statistical properties of the cover, which is stag analysis attempt to detect. Now, the job of stag analysis to detect traces, that where you have where you could where you you have stored information inside that cover. So he can observe that by observing different kind of traces. By using those traces, stag analyst get your information, or tries to get that where you have stored the information inside that image or a text or a video. The process of attempting to detect statistical traces is called statistical uh, stag analysis. Now here you can observe that where the stag analysis is. Like for example, as I have explained in the block diagram of steganography, that you need cover and you have the message which you want to send, to the receiver. So what steganography uh, does, that it converts your message into stago image, and this stago image will be sent with the key, and then this will then the extraction will be performed to get the information. But if you have this stago image and you don't have any key, and stago analysis try to get that algorithm, or get that mechanism to get your information. So there is a place where stag analysis applies on your data to get your secret message without uh, uh, having any key. Now, important aspect of stag analysis. So there are two important aspect of stag analysis or stag analysis: detecting hiding information and disabling steganography. So if he does this, that he uh, uh, disables steganography, so he can reveal your information and understand what you want to send to the receiver. Now, applications of steganography. So performing confidential communication, storing that and storing secret data inside your image, and protecting of data alteration, protect copyrights to maintain confidentiality. So definitely, if user will not, because in confidentiality, only authorization or only the access is granted to authorized user. Access is granted only to the authorized user. No other can get this. So no other can get this information. So steganography does that, it maintains confidentiality for you. Media database system and used in modern printers to maintain these applications. Advantages, difficult to detect, only receiver can detect it, and can be done faster by applying different kind of softwares, and provide better security by sharing information on a LAN, MAN and WAN. Where are they as there are many advantages of saying, but there are some disadvantages as well, that confidentiality maintained by the algorithm, and if this algorithm is known to the intruder, so then there is this technique is of no use. Password leakage may occur to unauthorized access of data. If technique is gone in the wrong hands, like hackers or a cracker, can be very dangerous to for all. Now, lecture number 12, Steganography, part 3. Now, this is the comparison between steganography and cryptography. So here you can see that I have listed basic operations, like what are so in case of goals, steganography goal is secret communication, whereas the goal of cryptography is data protection. Structure of message, no alteration is done in the structure of message, whereas in cryptography altered only of the transmission. Steganography, this is less popular, while cryptography is more commonly used method. Relies on operational keys, but this is optional in steganography that you use keys. I'll explain that in my next slides. So but if you use then it offers more security, whereas in cryptography key is a necessary requirement for encrypting your data. Supported security principles, so confidentiality and authentication, these are the security principles provided by the steganography, whereas the principle provided by the cryptographies are confidentiality, data integrity, authentication and non-repudiation. Techniques, so special domain, transform domain, model based and ad hoc systems are used in steganography, whereas in cryptography, transposition, substitution, stream cipher and block cipher techniques are used to convert the plain text to cipher text. Data visibility, never and it always you like if you remember when we were studying cryptography, so the data were traveling, but data was accessible, and data but we convert the plain text into cipher text. User cannot understand that, but in steganography, user even cannot determine that where the data is hidden inside that image or a video. So implement this kind of steganography is implemented in audio, video, image and text, whereas cryptography applies only on text files. Steganography, this is attacks, this is called stegoanalysis, where the attack on cryptography is called cryptanalysis. Now, this is a combination of cryptography and steganography. Like for example, if you have a plain text is encrypted, and encryption will be performed on it, and you will get ciphertext. Now this ciphertext will be hidden inside of cover image, and stego image will be created, and then this uh, stego image will be sent to the receiver, where the cipher text will be received, and then then decryption will be performed to convert the cipher text to plain text. So now you have two mechanisms. You have cryptography, and you have steganography. So with the help of cryptography, you convert the plain text to ciphertext, and then we store this ciphertext inside inside that image or a file. So if a user will not so intruder or malicious user, first he will not able to get the information that where the information is stored inside that information. But in case if he gets that information, he will not be able gets the information, as the information is encrypted, he will not be able to get the meaning of that. So that is how we can make our uh, uh, we can make the communication of the network more secure. So this is I have showed that using steganography and encryption, you can merge them and you can create more secure communication scheme. Now, these are the types of stegosystems. So there are three types of stegosystems, like pure stegosystem, secret key steganography, or a public key steganography. So in a pure stego key or steganography, no exchange of keys such as stego key, not much secure, because sender and receiver rely upon the assumption that there is no other party. So no key is used in such kind of stego system or steganography systems. Whereas in secret key steganography requires the exchange of secret key or stego key previous to communication, takes a cover message and embed the secret message inside of it by using a secret key, stego key. Only the parties knows about it, so only sender and receiver can, or the parties which know that key can decrypt or can understand that message. Whereas in public key steganography uses private and public key to secure communication between the parties. Sender use the public key during the encoding process, and private key uh, is used to decipher the secret message. Now, steganography versus watermarking. So, what are the differences between these two? So, changing the image in a way that only the sender and the intended recipient are able to detect. So, this is steganography. Whereas in watermarking, information which verifies is embedded into the digital image or a signal. These could either be audio, video, or picture. And water is of two types, visible and invisible, and typically this is water marking is visible. So you can see that information hiding, within information hiding you have is divided into two parts, like steganography. By using steganography you can hide your information, or by using watermark you can also hide your information. So the both techniques are used for hiding the information. These are the sources cited. You can visit these sources to explore more about this topic. So I hope that you will visit these sites and find out more about this topic. If you have any question, you can ask me through KCMS, WhatsApp, or you can email me. I'll be more than happy to answer your question. So it brings us to the end of this lecture. So till next lecture, Allah Hafiz.